Okay, so now we move on to unit 29. So unit 29 is a very short unit. So you just learned 3 new type of organic substance. So how to name aldehyde, how to name ketone, how to name ester. That's it. Okay, so this exercise, I think many of you made mistakes for the NC, but for the long question one, just a few mistakes. Okay, so the first one, you can see on both sides it got hydrogen attached to it, so it's actually an aldehyde, not a ketone. And for it to be a ketone, at least you need to have 3 carbons. Then the carbonyl group will be in the middle of the carbon chain. Otherwise, it's always at the end. Okay, so for this one, it should be the methanol. Yeah, if they miss the first part, they can always check the video later, okay? If I don't want it to last too long. I'm afraid I need to mute you. Okay, with me for the first part. First question, so that's okay. So for the first part, that's aldehyde. Okay, so if you see hydrogen attached to that carbonyl group, right, then it will be aldehyde. Okay, and then for the second one, okay, what is the correct structure formula for the compound 2-chloro-3-hydroxyl propanol? Okay, so for this one, first we find out the main part. We have propanol. Okay, and then we would write the propanol part first. Propanol, 3 carbon, and at the end we got the double bond O and H. And then let's fill in the rest. And then we need to label. Remember, we need to give the lowest number for the functional group. So that's 1, 2, 3. Okay, so after we name those groups, then we can add those branch to it. So chlorine is at position 2, so that's chlorine. And then 3 hydroxy group at position 3, so add OH2 here. Remember, for OH group, the carbon should attach to O, not to the middle or not to hydrogen, right? To O, because that's a short form. If you actually write or show all the bond, it should be carbon to oxygen and then to hydrogen, okay? So don't link this line to the middle or to hydrogen. That's inappropriate, okay? And then you fill in the rest with hydrogen, and you check your answer with all the options provided. And remember, I have said in order to distinguish between aldehyde and alcohol, for aldehyde, we switch the position of OH. So it will be HO. Okay, so you should choose between B and D. And then you further check the position of chlorine and OH group. So that will give you the answer should be B. Okay. And for next question, that's not a difficult one, but you need to read the question carefully. It asks you to name the functional group, not name the molecule, or not show the functional group structure. Okay, you just name the functional group. Okay, so the first one, you can see C double bond O, the carbonyl group in the middle, so it should be a ketone. The second one, okay, you can see the OH, okay? So OH, that's aldehyde. Okay, so I got a question for the second question. So why there is a bracket Where is the bracket? Are you talking about this question? That's just to show OH is a group. Like, it's not C to H and then to well, you can write without the bracket or with the bracket. It doesn't really matter that lot. Okay, so the bracket, yeah, as you like, you can ignore it if you want. Okay, and if we're back to this one, we finished the second one, HO, that's aldehyde. OH, that's alcohol. Okay, next one, COOH, that's the symbol for carboxylic acid. And then the next one, we got COO, so that's the functional group for ester. Okay, any question for this page? Okay, cool. Move on. Okay, so this one, the compound is methyl 2-methyl-propanoate. Okay, so if you see the ending, that shows you that's an ester. So ester is made up of 2 parts. Okay, and you should be able to draw the line. The left-hand side, on the first part, the methyl part, actually comes from the alcohol. And then the second part, that's from the carboxylic acid. Okay, so if we draw the 2 parts and then join them, so the methyl group would be CHH. And remember, the alcohol group will provide the C single bond to O part. And then on the right-hand side, that's from carboxylic acid. Okay, so this one is propanoate. So the longest carbon chain got 3 carbons in it. Okay, so let's draw that apart. Okay, so this one from the carboxylic acid part, it would be providing the C double bond O part, and then 3 carbon, the longest carbon chain. Okay, and remember it got a branch, that's 2-methyl. Okay, so that's position 1, position 2, position 3. So at position 2, it got a methyl group attached to it. Okay, and then you just complete the rest. And connect the 2 parts. And then you check which one matches with the structure that you have drawn. Okay, so it should be C. Any question for this? Okay, and then the next one is a easy question. Which one is a carboxylic acid? So you should have a COOH group. Okay, so of course it's D. Okay, and then to the naming and joint molecule part. Okay, so the first one, not a big problem. Just remember we need to give the lowest number for the functional group. Okay, so it's 1, 2, 3, 4, 5, 6. Okay, and we name it with the lowest number, so it should be hex 2ing. And also we got a methyl group attached to it, so it's 2-methyl hex 2ing. Okay, and for this one, so you can see it got a bromine attached to the carbon chain, and also it got an OH attached to it. So bromine would give it a prefix, so it's bromo. Okay, let's discuss the position later. And then the OH group, that's the functional group, it will show something as N. It should end in OL. Okay, and for the functional group, we should give the smallest number, so it will be 2O. Okay, and it got 5 carbons in it, so pent 2O. And if it's pent 2O, so that's 1, 2, 3, 4, 5. So it's 4 bromo pent 2O. Okay, and next one. Okay, most of you got it correct, so no problem. And this one, yeah, did pretty well. So you can identify this double bond O to an H. So that's an aldehyde. And you find the longest carbon chain, 1, 2, 3, 4. So butanol. And then you got the methyl group attached at position 3. So 3-methyl butanol. Next one is butanone. Okay, so for this one, remember there is no need to mention the position of ONE for the carbonyl group, because if you put it here, okay, if I put it here, move to this position, then you will name it as 1, 2, 3, 4. It's still at the same position, position 2. Okay, you will not switch to position 3. It's not the lowest number. So no need to give the number for the carbonyl group. So just butanol. Okay. And the next one, if you see C double bond O and then O, that means it's an ester. So we break it here. Draw a line and break it here. So the right-hand side part, that's from alcohol. The main part is from carboxylic acid. Okay, so we name the alcohol part first and change the ending into YL. So that's methyl. And then the second part, we have 1, 2, 3, 4. 4 carbons in the longest carbon chain. So that's butanoic acid. We change the ending into OA. So that's butanoate. So methyl butanoate. And then the next one, again, we use the same method. So we break it here. Sorry. And right-hand side is from the alcohol, so with 2 carbons, so it's ethyl. And then left-hand side is from carboxylic acid. Okay, 1, 2, 3, 4. So it should be 3-methyl butanoate. Okay, so carboxylic acid is a carbon 1, 1, 2, 3, 4. Okay, find the longest chain and also find the branch, and then you can name it properly. Right, next one, 3-methyl pent 2-on. Okay, so for this one, again, we find the functional group, the carbonyl group. We want to give it the smallest number, so we need to name it from the right-hand side, 1, 2, 3, 4, 5. So that's the longest chain. And then you got this branch, which is a methyl group at position 3. Okay, and then the most difficult questions, the last two. For this one, you need to note that the double bond is a functional group. And when you draw the longest carbon chain, you need to include all the double bond, all the functional group. So your longest, the longest carbon chain will start from here, go through the double bond into here. So there are 6 carbon in it, and there are 3 double bond. Okay, so it should be hexa 135 tri 3 double bond. And remember, if you have watched the video that made by Teacher Titan that tells you how to name a molecule with more than 1 double bond, okay, or more than 1 OH group, because it's missing a vowel, so you need to add a at the end. So it's not hex 135 triene, it's hexa 135 triene. And then you just need to, okay, also include the also include the 2 branches. Okay, so there are 2 ethyl group. One is at position 3. Okay, 1, 2, 1, 2, 3. The other one at position 4. Okay, so 3, 4 diethyl hexa 135 triene. Okay, and then last one. Again, you can see C double bond O to O. Okay, so we break it here. So for the alcohol part, I think it's pretty easy. Okay, so you can find the longest chain is this part. Okay, 3 carbon. So it's propyl and there is branch. So 2 methyl propyl. But for the left-hand side, okay, you can see this molecule, first it's a carboxylic acid, but also it got a double bond in it. Okay, so how do we name this two? Okay, so for this part, I want you to jot it down for IUPAC naming rules. They have a priority for those functional groups. So the priority should be alcohol is more important than alkene. It's more important than haloalkane. Haloalkane. More important than the just alkane group. Okay, so for this molecule, okay, so carboxylic acid is higher priority than the double bond alkene. So we should use a main part to number it. Okay, so main part it should be 1, 2, 3, 4, 5. Okay, so it's pentanoic acid. Okay, first, but for pentanoic acid, I didn't mention the double bond. Okay, and you can see double bond. The smallest number for the double bond that the double bond start is at carbon 3. Okay, so it should be pent 3 in noic acid. Okay, so that's for the acid part. And then we change the ending. Okay, then it will become pent 3 enoate. It's a bit strange, but yeah, that's a name. Okay. Okay, so to give you one more example about the priority, for example, if I have this molecule, okay, so first it got a double bond, and then it also have the OH group. Okay, yes, let me go through the easy example. Okay, so this one, if I write out, okay, so now I have this example. Okay, so for this molecule, you can see it got 2 functional group. Okay, so one is the OH group. The other one is here, the double bond. Okay, so which one should we give the lowest number? So according to IUPAC naming rules, they have a priority list. Okay, and on this list, alkene, which is alcohol, has a higher priority than alkene, than the double bond. Okay, so we need to give the alcohol part, alcohol functional group, OH group, the lowest number. Okay, so in order to maintain the lowest number for OH group, we should number it from the left-hand side. Okay, so it will be carbon 1, 2, 3, 4, like this. So the name for this molecule should be but 3 in 2 O. Okay, but 3 in 2 O. Okay, so you should not do it the other way. Okay, it's Okay, because this one, it doesn't have dying or trying, just one double bond. Okay, so similarly, if we look back at this example, okay, so our carboxylic acid has a higher priority. So we need to make the numbering system that suits the carboxylic acid. That's why we number this carbon as number 1. And then follow this 1, 2, 3, 4, 5. Okay, and then that will be carbon 3, the double bond. Hence, that's pent 3 enoate. Okay, and then refer to your question, tetroin. Yes. Oh, if it got more double bond, yeah, then you need to add that as well. Okay. So any more questions so far about the naming? Okay, if no, then we move on. All right, so this one is a methanol, okay? So one carbon and it got a OH group attached to it, so alcohol. Okay, so the first one, it is immiscible with water, so it similar or same meaning as it's insoluble with water. Okay, so whether it's insoluble or soluble, we check whether it can form hydrogen bond with water molecule. Okay, so for this molecule, because we have an OH group, so it can form hydrogen bond with water molecule. So it's soluble in water. So A is wrong. Sorry, the first statement is wrong. It can form hydrogen bond. Okay, and then second, it is neutral to litmus solution. Yes, for alcohol, they're pretty stable molecules, so it would not be ionized to give H plus or OH minus. Okay, so it just stay on its own, so it's neutral. So that's correct. And then it burns with a non-luminous flame. Okay, so it can burn completely, and it only got one carbon center, so very small molecules. So yes, so the answer should be D. Okay, and next one, arrange the boiling point of the following compound in ascending order and explain your answer. So for those who have handed in the homework, so they all got the most of them got the answer correct. So it should be A, the lowest, C, the highest. So first, you need to have this sentence. It's very important that you have this pattern. Okay, for unit 24 questions and for this unit question, you need to have that sentence. The boiling point depends on the strength of intermolecular forces. Okay, and then you will mention A would not be able to form hydrogen bond, or A can only form weak van der Waals forces. Hence, that's the lowest. And then you compare B and C. B and C can both form hydrogen bond, but C, because it's a carboxylic acid, it can form dimer. Okay, so it will have a greater molecular size. Okay, and due to the hydrogen bond, it can have a more compact structure. Hence, it will have a higher boiling point than B. Okay, so among three, C has the highest. Okay, so make sure you use those words that have that shows that you are comparing two things or three things. Okay, and for question 3, pretty standard. You divide it by atomic number or molar mass, and then you work out the ratio, work out empirical formula, and from empirical formula, easy to get the molecular formula. Okay, I saw no problem with this one. And the last part, the 7 possible structures for that molecule. Okay, any reasonable answer will be correct. Here I just provide some possible ways to arrange it. Okay, but if you are not sure about the total amount of hydrogen ion, then do draw the complete structure formula and do calculate all the number of different atoms. Okay. So that's the end for unit 29 exercise. Any question about that unit? Okay. Yep. If you have any more questions, just message me or leave a comment on Google Classroom. Find a way that that you find comfortable with. And yeah, I think that's all for today. And thanks for coming, and thanks for listening and for all your questions. Okay, bye.